We are being recorded. Welcome, everybody. Excited to kick off the first session of the security track of Block 3 of Kernel. I am the track leader, Dr. Corey Petty. I'm the Chief Security Officer of Status. The concept of this session, lecture, whatever you want to call it, is Web3 security mindset. We'll get more into that, so as who I am and what we're doing here in a little bit. So, standard outline. I'll talk about who, why, how, and what, all around kind of the concepts, who's doing it, why we're doing it, how you do it, and what are the things we're going to be focusing on, and how this course gets all that done. And at the end of that, we'll wrap it up. And as Sachin said right before we started, if you would like to have any questions or chat or comments, keep it, direct it towards the track security channel in the Slack. So that way we maintain history of it and everyone knows who everyone is, and it's just pretty much better that way. So let's get started. Who are we and why should you listen to us? You signed up for the track security or security track in Kernel Block 3 to try and learn about what security is in the Web3 ecosystem. Why are we fit to help you figure out what that is? In terms of the overall hierarchy, I represent Status, and you can find the Twitter handles of relevant people within the Status organization that have helped me do this. Simona Pop, me, Sirhan, which is a new security engineer, and this is partnered with Gitcoin, of course, for Kernel. So you have Gitcoin and Sachin and Vivek doing those things. There's so many more people involved with this. If you look at who's involved just within the track security channel and the various partners that have helped us put together content, serve as mentors, field questions, give you additional information as to where to go once we introduce you to the concepts, they're all in the track security channel. And it just titans in the industry, those who have defined best practices, those who create the tooling we're going to be talking about, you name it, they're all pretty much here. So you've come to a really good place in terms of not only discovering what it means to think about this industry, but also finding the tooling that helps you become a professional in whatever way you'd like to, and the people who can help you learn how to use it. So a little bit about me. My background is in computational chemical physics. I spent most of my life, or most of my early professional career, trying to solve some of the hardest chemistry problems on supercomputers, which gave me an interesting skill set, and I enjoyed it a lot. But my fascination with blockchain quickly led me to leave academia and focus all of my time thinking about the concept of security and what that means in the blockchain ecosystem. That's been maybe, 7 or 8 years now since I've done that. And I haven't looked back, and I don't plan to really ever. So additional things that I do a myriad of things besides work at Status and do this. I also run a couple podcasts that are focused on blockchain, hashing it out, being a very technical dive as to like how things work, why they work, why people think that the stuff that they're doing works, and I try and poke holes in it. And then the Bitcoin podcast, which is more of I'd call it a infotainment type of podcast where we joke around and talk about current events, news, and so on and so forth, and bring on topical guests that range from, you name it. If they're interested and it impacts their lives, we want to talk to them and have some fun in the process. So why are you doing any of this? What's the point? There's a couple different types of people that I'm going to name that may be interested in learning about security and the reasons behind why they'd like to learn about security in the blockchain ecosystem. And as a developer, which is a main person in these groups of people, is they want to make their software more secure. They want to find problems in software and help them and help solve them. They want to protect their users to make sure the software that they're building doesn't go wrong and people lose funds, because when things go wrong in crypto, people lose funds. They also want to find like-minded individuals to collaborate with, learn from, talk to, More often than not, those of us who've been in this industry for a long time have been the weird ones in their friends group. And we seek to find groups of people on the internet to help so we can actually talk to this stuff about and not just field questions about what coins people should buy. So this is a great place for that. As security experts, we'd like to bolster our security offerings. The more we learn about the concepts of security and the available tooling, the better we can provide security services to those in need. And trust me, there's plenty of people in need and not a lot of people who are able to do it. So the more time you spend trying to bolster those services, the more likely you're going to be successful in this industry. Also, people are here to help find talent. So as you learn more and start asking questions, more often than not, you're going to find people that are going to be able to not only answer those questions, but also maybe bring you in as an intern, or if you show promise, take you in and maybe give you a job. And another part, since this space is incredibly open, we seek to help establish best practices so that those who are learning understand what the best way to do things is as fast as possible, so they can get to the point where we are quickly and help start contributing. As an organization, different companies want to do stuff from a different perspective, and that's efficiently engage in security audits. We build software. We may not have the expertise to fully understand whether or not we're covering. We engaged in third parties to help get reviews. That process is not easy. So the better we understand the concept of security, the better we can engage external contributors to help us give us more confidence as to whether or not our software or organization is as secure as it needs to be. We need to properly assess risk. In order to do this type of stuff, we need to understand security to figure out where the risk is in our organization or software, and what mitigations we put in place to handle it. And we're going to talk all about that and how to think about it throughout this course. We've got to protect our organizational assets. As we know, not your keys, not your crypto. Well, if you have a rogue person in the organization and they have access to the keys, it's not your organization's crypto anymore, is it? You got to keep up with best practices. That's ubiquitous across the whole industry, and also find talent to hire. So I like to think in things of terms of questions. And this quote from Neil deGrasse Tyson has always been something I fall back to kind of explain that. And I'll read it out loud. My investment of time as an educator, in my judgment, is best served teaching people how to think about the world around them. Teach them how to pose a question, how to judge whether one thing is true versus the other. And in this track, our goal is to help you become better at asking questions through deeper understanding of how things fit together. I'm going to try and give you a framework to think about security in this industry. Additionally, I want to aim to give you the right people to aim those questions at. First step is figuring out what type of thing to ask. The next person is figuring out who to ask it to so you get a good answer. And why we do this is because we need more people asking good questions to the right people, so that better things are getting secured and more attention is being spent on where value is. And so a little overview on how this track works, how the sessions work, and what's involved in each different section. I've broken the rest of there's 4 chunks total, this one being the first one. I've broken the remaining ones up into what I view as like broad subsections of security. First one being smart contracts. And this is what most attention actually goes to, because more often than not, when something goes wrong, it's about a hack in a smart contract and how much money gets leaked from it. Well, there's a lot of other stuff that comes into play in terms of security in this industry. So I want to cover those too. And that comes into supporting infrastructure. What's all the other stuff that goes around making sure those smart contracts work, monitoring them, serving that information to the web UI, so on and so forth. That's going to be the next section. That's going to be covered by Open Zeppelin, with the first being covered by Carl Farderson here with best practices in DeFi safety. And finally, we're going to go over organizational security, which is how do we handle this new type of asset class and the underlying technology that wields it within the organization securely? How do we monitor things? How do we make sure that our pipeline for security software development is set up correctly? How do we deal with employee churn and access control to various assets within the company, things like that? And there's a large overlap between Web3 and non-Web3 processors here, but you still have to understand how that concept changes. And we're going to do that through two main skills that I want you to have by the end of this course. Maybe not like be incredibly proficient at, but you're going to have experience doing them if you actually participate and try. The first one being threat modeling. That's generally, given a project, how can I identify where the risk is as well as how it's mitigated? I want you to be able to approach a project and break it apart and understand how it all fits together, what the pipes are that connect the different pieces, and where the risk lies, and what like security mechanisms are in place to help mitigate people getting access to that value that they shouldn't. You should be able to do this as best as possible if you're ever going to think about security properly. And this skill is one of the most useful skills you can have throughout the entire industry, regardless of what you're doing and what your role is. But that being said, it's incredibly broad. And what domain expertise or like specialty you bring to the table will have a unique perspective on how to do this. And that's going to be important. So like try to bring your specialty to the table and think about these things from what you know already. And the second one's going to be best practices. Given a project, how can, sorry, my picture here is covering up the text. Given a project, how can I assess whether or not it is being done in the most effective manner? This is an incredibly open ecosystem. We developed best practices so that we minimize the risk of starting new projects. We can see what's worked good or most effectively over a long period of time. What contract protocols or methods or patterns are used most likely to secure the most value. We should probably use those if we do something similar. We're going to look at what those are and how to look at a project and see whether or not they're applying them. So, in short, each subsection lasts 2 weeks and contains the following: a 1 hour lesson, which is this, and some questions along with it, 1 hour threat modeling workshop on a given project associated with the lesson, and a 1 hour best practices review to look at a project and start trying to learn what best practices are, where they exist, and how to see whether or not that project is applying them appropriately. Give them a grade. And in addition to that, we'll have a myriad of other content within the Slack, whether through Junto's organizational participant from all the mentors, all kinds of things. So make sure you're keeping up with the chat in the Slack and the rest of other channels to participate in whatever way you can. So on to more content. What the hell is security? Put simply, in my opinion, security is the process of protecting quote unquote value. And I've created a diagram here to try and illustrate this as best as I possibly can. I want you to think about this diagram and all the different ways in which different perspectives and parts of this ecosystem apply to this diagram and how things change, right? So it starts with value. Very broad concept of value. That can be assets locked in a smart contract. That can be social value. That can be PII in an organizational's infrastructure or personal identifiable information in infrastructure. It can be all kinds of things. It's a very broad concept that I want you to think about. And more generally, what we do as an organization in security is we define access, which controls that value. We define who gets to touch it, who gets to change it, who doesn't, and mechanisms around making sure that those who shouldn't can't. This is like only owner in a smart contract, or dealing with SSH keys for personal or for organizational infrastructure, all kinds of things like that. And then as an organization, we define process, which we have processes which define access. This is the process that we have as an organization when we need to change access, how we come up with them, how we think about who needs to access these things, and also the process of when things go wrong, how do we use the access controls we have to protect value? On the other side of things, we have vulnerabilities. Vulnerabilities both circumvent access and provide undesired access or damage to value. This is the type of things people try to use to circumvent access to try and do something with the value in place. And And finally, we have threats. Threats are people or things that exploit vulnerabilities to circumvent access and mess with value. And it all kind of goes full circle here and how it all fits together. And it's probably more complicated than this, but like if you can understand this concept, then you've got a great foundation to get started. And process, of course, monitors, predicts, and responds to threats so that they can provide access, define access controls that keep vulnerabilities from getting in. So this is the diagram, and we're going to talk about it over and over again throughout this course. And these are the actors or the players inside of this ecosystem that do various things on this diagram. I'm going to move this thing quick. There we go. That's better. And I lost my mouse. Cool. Whatever. So what happened to my mouse? One moment. My mouse just literally left. I no longer have it. Oh, that's really neat. I think my computer has frozen.
Do you want me to share the screen instead, Corey?
Maybe. You might need to share screen and change the slides for me because I literally cannot. I don't have a mouse anymore.
I'll get it ready, yeah. By the way, okay, your computer is stuck. I was going to ask you to check the chat and Slack, but
thank you, Andy. Oh, I got it back. I don't know what happened, but I got it back. We're good.
Amazing.
Cool. So thank you, presentation gods, for staying with me here. All right. So these are the actors we have that are kind of around the concept of security in this ecosystem. We're going to start with the security engineers or the organization, right? The organization defines process. This is the domain in which they spend most of their attention, right? They define process, which does the access, which controls value. And they try their best to predict, monitor, and respond to threats that are available in the ecosystem. And they do that. I mean, there should be an arrow maybe to process and to vulnerabilities because you have to monitor for all the available vulnerabilities, but you get the idea. These are threat actors. These are the people who are the types of people that are threats by taking advantage of exploiting vulnerabilities to get access to value. These are the people who are trying to break your system, or in some cases, your own users that do a little more by messing up access control, by doing things that they're not supposed to with the software you create. So if you think about a threat actor, some potential threat actors actually are your user base. You need to keep that in mind when designing software and giving people options to do things. And finally, the security engineer, which is the person that kind of has to play both sides. They need to know it all. And this is why it's an incredibly difficult thing to do, is because you need to understand both sides. You need to think both from this perspective of a software engineer and organization in terms of what they want and how they go about doing it, as well as the threat actor in getting around all those mitigations and what's available to them. So it's a tremendous domain to keep up with, but it's worthwhile. So what's new? What's different between the internet and blockchain infrastructure? And I try to use this anecdote, I guess, over and over when I try to explain this to people. In traditional security, you have this concept of a castle. We have value, we lock it up, and we build a castle around it. We put whatever we can around this castle to make sure that we have full control over who gets in, who gets out. We build moats. We do whatever we can to protect the value within this castle, and we have full control over it. And more often than not, it's getting better over the time in terms of like zero trust models and all kinds of different things in terms of how security has changed over the years. But generally speaking, it's how do we protect the castle? And we have a lot of controls that we can put on as custodians of value to impose on our users. But as we all know, when you build castles, people come down and break them. And when you pool value, and you pull access to that value into a very small number of hands, you would create things like honeypots and large places for people to go that have very large consequences. And so what came along with blockchain is we try to decentralize all the things. We're like, well, it's no longer good to pool all these resources and access them to small amounts of people. They have too much power. And when things go wrong, it's too bad. We don't like this, right? And so we just ran with this mantra of let's decentralize all the things. And in the process of that, we destroyed the castle. We broke it up into a bunch of little small castles and made weird, confusing pipes and connecting them. And so in some cases, it made things better so that if a single place or single user gets exploited, not as much damage is done across the whole system. But it's much more complicated when you have to reason about how security works and what happens in the space of things that can go wrong. So I'm going to ask a question. As we remove the castle and push ownership and the responsibility to the edges, how does that impact security? And this, in my opinion, is the main focus of what Web3, the differences of Web3 security is with traditional security. Our focus changes. A lot of the same underlying principles are the same, but the perspective of how we view them changes drastically. So, as an example, education requirements skyrocket. In order for us to provide good security, we have to educate our users a lot because they're the ones that have all the access. So if we think about the diagram, the process changes quite a bit. We're spending more time focusing on education, and the types of access mechanisms we have are very decentralized. They're in the hands of the user because they're the ones that control all the value. Individual influence plummets. So a single person doesn't have a lot of access. And so how do you go, the types of things you do to come up with access control has to be broadly scoped to every single type of user you have. And furthermore, like it's good because an individual threat actor may not have nearly as much impact on your ecosystem. Attacks on ignorance become incredibly efficient for the same reasons. The types of threats change. What's the most difficult and pervasive issue we have in crypto? That's phishing. And that's getting people to input their private keys and seed phrases, input their passwords on something that looks official but isn't. Because unlike email phishing or something like that, where I get access to your email and then I do a bunch of bad things. In crypto, if you get phished and you give away your seed phrase, your money is gone and there's nobody to give it back. The impact drastically becomes higher, while the cost of the threat actor remains the same or gets better over time. So, and user preference variability leads to option paralysis. So like you have to ask yourself the question, how many options should we give our users? What type of decisions should we make on behalf of our users? Then more often than not, ideally speaking, you want to give them the option to do whatever they want. But more options you give somebody, the more difficult it is for them to make the right decision at the right time, and for you to make software that gives them the information they need to make it. Another concept of this is kind of continuing on that last thread, and it's summed up through this KCD comic. And child, let me quickly explain ... And that's how asymmetric cryptography works. Anyone who's been a fan of this, who's then tried to tell their friends about how Bitcoin works, or even worse, how Ethereum works, or even worse, how layer 2s work, has had to try to explain asymmetric cryptography, consensus algorithms, so on and so forth. Anyone who's tried to like on-ramp their mom into a wallet so they can hold some ether has inevitably dealt with a bunch of technical jargon in which their parents or whoever says, this is stupid, I don't get it, it's dumb. And that leads to what happens as we rely more and more on novel cryptography and difficult technology, both from a systemic point of view as well as user intuition. So we force user behavior to change. This is the most difficult thing. More often than not, when you learn traditional security, you say the best way to defend your system is to make the attacker change their behavior because people don't like changing their behavior. Well, this technology forces users to change their behavior too, if they're going to use this stuff correctly. It's a really hard thing to do. Implementation risk soars because we're using more and more difficult things to do. And the type of expert assessments we need in order to make sure we're doing that implementation correctly gets harder and harder and harder to find and more expensive to get. And furthermore, because everything is dispersed, monitoring becomes very, very difficult, particularly when we start using things like privacy technology that shields information from ourselves. A lot of the ideals of cryptocurrency and blockchain is to not have power and not know anything about your users. The more you do that, the more difficult it is for you to find problems within your system and the behavior of your users and anomalous behavior within that set. So once again, thinking about the diagram, how do these types of concepts that I've just mentioned change how you view the diagram and what circles get bigger or smaller or more focused on? Finally, the final example, everything is in the clear. You can't hide anything. One of the main tenets of open and permissionless blockchains is that it needs to be open source. How can you trust it if you don't know how it works? It needs to be verifiable by experts and people and understand that the source code that I'm running on my computer is what's been built by the software developers. So what's gained and lost when everything becomes visible? Concepts of security through obscurity vanish. You can no longer rely on obscuring things as a form of security. Your security needs to be good enough because everyone's going to know what it is, and they're going to know all the available ways to get around it. So it just better be good enough. That's all there is to it. Structured data is ubiquitous, leaning towards heavier and heavier usage of machine learning to find anomalous behavior. This is both good and bad. Best practices are easy to emulate. So because everything is open, I don't have to guess what a given successful company is doing. I can go look at their code. I can decompile their smart contracts. I can do whatever I want and see exactly the mechanisms and methods they're using and emulate them, which allows us as security engineers and software developers to make better, more secure code based on what's already securing all of value at risk today. And obviously, if everything's in the open, I know where value is because it's out in the open. So I know what to attack if I'm a threat actor. And I can go on and on and on, and it becomes difficult. So how do I compartmentalize all this? How do I fit this stuff into neat buckets so I can maybe focus on one thing and one thing only based on what I'm interested in? Once again, I've broken this up into 3 broadly spaced subsections: smart contracts, which is where most of the value sits and the access control. Well, most of the explicit, obvious value sits and the access controls around them. And supporting infrastructure. What makes this stuff work? It makes sure the data within it gets to the user correctly. How can I be sure that the software I'm using that forms a transaction that makes it to the blockchain is formed correctly, and my wallet isn't signing some rogue thing that steals all my money? There's plenty of examples of this. And finally, organizational security. How do I make sure that the people who are building the software are doing it appropriately and don't abscond with all the funds, which, once again, happens quite a bit. So break these down a little more. Smart contracts. Fun way of thinking about this is, hey, giant, expensive, and slow computer, can you do this for me? That's basically what these things are. They're giant, expensive, slow computers, but we don't have to trust them. We know they're going to work the way they're supposed to. So the types of things we're going to try and go over in that section is automated tooling. How can software find issues for me without me asking too many questions? Manual review. When that is finished, I know there's still questions. What are the types of things only a human can find once automated tooling has run its course? Formal verification, which is a kind of an overlap of the two, which is, how can I be sure this thing works exactly the way I think it does? And what's the highest level of guarantees I can get from that? And then finally, best practices. What's everyone else done in this space that leads to sustained success? How do I understand that and then apply it to what I want to build or what I'm thinking about investing in? Supporting infrastructure. How is this series of tubes connected to each other? And that's going to cover things like nodes. How does the network computers give data security guarantees? Front ends and hosting. Where does this software actually live? What happens in the process between the blockchain data and my browser, for example? Wallets and public key infrastructure. How are keys stored? And subsequently, how are they used to make good transactions? Who gets access to these things, and how is that access rotated over time? How do you assess the risk of a given access control mechanism for any public key infrastructure. Then you have monitoring and alerting. How can I know when something happens? How do I get alerted? What's my time to response? And is that good enough for mitigating a given problem? And then development frameworks. What type of decisions are being made when I use software that makes it easier for me to build things? And is that going to be good enough for the type of risk that I have with a given project? And finally, organizational security. How do we do security? And that is access control. How do we manage it? There's a new type of assets. We have to deal with new types of ways of managing them, particularly with respect to employee churn. How do I make sure that a given wallet can't be stolen by someone who leaves an organization, even on good terms? Education, because we've given up all of our power. What type of decisions do we make on behalf of others versus give them full control? What's the kind of give and take of that type of thing? Incident response, when something goes wrong, because it will. Do we know what to do? Do we know what to look for to make sure that we know something went wrong? And how fast can we do that? Do we have processes set up such that if the lead of the security team is out, everyone else can figure out what to do and handle it? Or get a hold of them if he or she happens to be sleeping? And the software development lifecycle. What type of guarantees do we have in the process of developing our software to help bolster our security stance? And we're going to do this finally, first through like what I think is a really good way of doing things, which is learning the broad concepts, understanding what tooling is available within that subsection, apply a threat model to a project that's associated with that subsection, and practice looking at how risk is defined and controlled within that project. How do we understand risk? And then the underlying control mechanisms that are used to protect it. And then how can the tooling available that we just learned about fix those, like help mitigate that risk? And finally, best practices. What are people currently doing in this industry around this topic? And how do we learn more about what those things are doing? How do we keep track of them? And how do we figure out whether or not any given project we want to look at is doing those things? And so that's all I have for today. I tried to go as fast as possible, so I leave plenty of time for questions. But sort of wrap up, this space is huge and it grows incredibly fast. You can't know everything, but you can know a lot of people that help you understand things, and it's easy to learn, and we want to help you. Success is heavily dependent upon how fast you can understand things. Everything is a risk assessment, and your perspective makes a severe difference, whether you're looking at things from like a traditional Web 2.0 perspective to Web 3.0 perspective, and how you understand stuff and what skills you have to bring to the table. So in short, what this whole program is about, and the kernel program, build a community, ask good questions, so let's learn from each other. Thank you for listening, and I'm going to pass it on over to Carl, which is going to give you an overview of the best practices process and how to sign up for that.
Great. Yeah, I'll share my screen, then we'll get going.
And I've seen a bunch of questions here in the Slack here, and I'll try and start covering those after Carl's done.
Great. So with best practices, we'll be best practicing our way to a better Web3. And just to give a quick review, our first review was of Tonic Finance with Tony Snark. And he said that the best practices were the first external developers to look at Swirl Protocol. And despite being the first project that we reviewed, our attention to detail, professionalism was remarkable. And he highly recommended us as a sanity check for code and support on best practices advice. Shortly after we reviewed his project, it was all acquired by Inverse Finance for $1.6 million. So there's a huge weakness in the current audit landscape, and it's anything from price, wait times, lack of resources, and basic errors. And with them, they're all kind of glaring in the audit space. And so best practices aims to solve a lot of these weaknesses, whether it is being more affordable, taking less time, providing more resources so that people that want to be in the space are able to learn, and avoiding those basic errors that can be circumvented from the start. So some goals of the best practicers for developers like you guys, you can engage in code review without having super technical knowledge, which is great, as then you can kind of get your in-hands experience and collaborate with new people and build relationships. A big part of the kernel is meeting other builders in Web3. And so best practicers will be a great way to work directly with other people in the kernel and learn some more about each other. But also when it comes to auditors and audit firms, they can focus on the technicals and not the small things. So they can also draw from the best practicers team for future auditors. So right now, there's not really a good onboarding process to become an auditor. It's either like you are or not. And so with this, it's a nice transitional period to be able to draw from the best practicers. And for reviewed projects as well, it's extremely important to have standardized code so that way protocols can integrate yours, as well as getting engagement from new developers. If you have poor documentation, for example, it's going to be very hard for developers to use your contracts. So in addition, it's just stuff like a basic sanity check and giving an initial review prior to a full audit. So lots of goals that we can kind of accomplish with the best practicers. So our process that we'll have with the best practicers is really broken into 4 parts. So when we start, we have a GitHub project to review and track progress. And for each best practice, we'll have an issue where we will assign 2 people to each issue. You will then have 5 days to submit a pull request of your review that you have completed with your teammates for the best practice. And then for the next 5 days, we will cross-review a different pull request. So that way, not only do you have experience submitting your own best practice review, you can also look at another best practice review and give that feedback so that each best practice is kind of covered by 4 people instead of 2. After those 10 days in total, we'll have 3 days to submit those proofread suggestions. So the teams that submitted the original pull request will update their feedback. And from there, we'll give a review completion of where we gather and combine reports and we debrief the project team with results. So all in all, it takes about 2 weeks. We could kind of speed up the process, but this is meant to give you guys time to work on this while also having your own primary occupations, as we know kernel members have many other commitments. So some best practices that we'll target. So just kind of an idea of what you'll get to review is stuff like code documentation, whether it's diagrams or readability. NatSpec, which is really underrated, but highly essential. Testing. Testing gives really good narratives and makes sure that a lot of the edge cases of how you expect code to work will function. Access control, making sure that functions are only callable and state variables are only accessed by certain parties. And then code standardization, which OpenZeppelin is a very popular framework for simplifying code. And as all OpenZeppelin contracts are well audited, there's no real reason to reinvent the wheel when it comes to ownership, ERC20s, et cetera, when you can simply import OpenZeppelin packages to do just that. So some next steps, we have the project best practicers on Slack. This Friday, we have a Junto at 8 a.m. Pacific. So for this, we're only accepting the first 10 people to sign up for this first review. And so we'll have a review every 2 weeks. And so for each review, we'll only have 10 people within the best practice, so that, or in total, so that way we don't have too many people working on each best practice. And then coming to Explore, we have our own GitHub repo where you can see the 2 projects that we've reviewed, which is Tonic Finance and ethblock.art. Note that both of those repositories are either private or inactive. So some of the links to look at the original repos we reviewed may be broken. And then wayward.org is the first project we'll review. They were quoted about $100,000 for an audit from an audit firm. So this way we can actually give them some speed up so that they can make sure that their project is up to the standards that they should expect. So yes, that is the best practices. Oh,
Awesome.
and I'll share the slide deck with you guys so you can find the links and all that jazz. I'll shoot it in the Slack.
Yeah, in the Slack, I'm going to put directly the Junto link, which, as mentioned, has a 10-person limit. This is to review the first contracts. Carl, did you mention anything about Wayward? Anything you want to say in detail there? Or?
Not exactly. I have the link so people can research it and decide if that's what they want to review. So I don't think I should take up too much time with it.
Cool.
I've got some answered some questions in the Slack. You can go read them. One of them was more of a general question, which is maybe better for an explanation. From Marcel, question: do you think UX will ever be as simple as the traditional email password model? Would you argue that UX, user experience, complexity might be necessary or a trade-off? For example, not needing to trust more middlemen. That's a hard topic, and it goes back to what I said earlier about kind of the it's a requirement if we want people to use this technology the way it's meant to be used for them to change their behavior. So in some sense, getting to the username password will be harder because it's going to require them to learn something new and not do something that the internet has kind of forced upon them via a random username you make up and a terrible password more often than not, unless they're using something like a password manager, which most people aren't. And it has to shift to managing a set of keys, because you can ostensibly use keys to log into anything and use those keys as your identity. And that's a much better security model, but it comes with the risk of managing those keys appropriately. So that user now has to make sure that they understand the concept of managing keys and what that means. And they can't click the "I forgot my password" button. That no longer works unless you do things like build custodial solutions, which will continue to happen and are perfectly fine, assuming the user understands the risks involved. So things like Coinbase manage your keys for you. So you can click that "I forgot my password" button and you can get your money back. But you give up a lot in the process. And I think it's going to be a while before we can hopefully transition to better ways of doing things such that you don't need to do that. Like I see things like Coinbase as stepping stones in the interim of people learning to change their behavior and us as software developers coming up with better ways of doing things. For instance, quality protocols of social recovery that allow you to reconstruct your keys by asking a friend's network based on a given set of value, right? So if it's, you're willing to do this with 3 of 5 friends for $1,000, that like something that secures $1,000. Okay, cool. Let's do a social recovery scheme such that if I lose my phone and I don't have my seed phrase or whatever it is at that time, I can just I can just prove to three of a set of 5 friends that I am who I am. And they say, cool. And it automatically reconstructs my keys without any one of them actually knowing all the information. So there's things that we can do to make it better or as good in terms of managing your identity and logging into things in the UX. In some cases, it's going to be a lot better. But on the other hand, like how you look at it, it's going to be harder to get there. So maybe a short way of answering your question is it'll be that or better, but it's going to be a long road to get there.
Corey, 2 of the questions from earlier on in your talk are perhaps interesting also for you to look at. The one from Driv, he says, can you draw parallels with the traditional cybersecurity roles, red, blue teaming, cyber threat intelligence of threat actors and so on, and how they're being adopted to the Web3 smart contracts, full stack security audit space? And another from Marcel, which is asking, is this track solely focused on Ethereum Solidity and the smart contract parts, or is it more abstract? If so, what is your stance on other languages, e.g. Viper or Rust, which quite easily compiles to WASM and might thus play a greater role in ETH2 with eWASM and many other blockchains?
All right, my camera crapped the bed, so give me a second. The first part was We'll scroll up and just read it while you said it. Gotta love only computers working, screwing up whenever you use them. Can you repeat the first one real quick?
Sure. It's about parallels between traditional cybersecurity roles like red-blue teaming and cyber threat intelligence and what's going on in the Web3 smart contract space.
Yeah, it's still very valuable. I'm going to turn my video off because it seems to be breaking. Zoom's quitting on me. There's a tremendous amount of overlap between what we've learned and gained from Web 2 or traditional security. And what I think is the most important is that everything in traditional security is valuable. All the lessons we've learned, it's more about the perspectives of how the perspective shifts on where value lies and how it's accessed. And then how attackers are forced to change their behavior too, and the types of things that are available to them that may be more or less efficient. It's like the example for phishing, right? Phishing is way more valuable and efficient for Web3, because if you steal people's keys through a phishing mechanism, then you steal all their value. And that means that, like, if we're going to do things like red-blue teaming, the focus on the types of stuff we're going to focus on are very different. And so, there's so much to be learned and gained. And since the security ecosystem is just now getting to the threshold of legitimacy that a lot of quality talent is entering and starting to help us get to that point, we're going to see the security stance of organizations drastically increase, because they're bringing that expertise in and also starting to understand how things change, because they're starting to learn about crypto and blockchain and how they have to change what they've learned in order to be as effective as they used to be. And that last one was, let's see, from Marcel again. You can hear me, right?
We can.
All right, I guess it's just my video that's breaking Zoom. Is this track solely focusing on Ethereum Solidity and the smart contract part, or is it more abstract? So what is your stance on other languages, Viper, Rust, which quite easy to compile the WASM, might play a greater role in F2 if you want. Yeah, so this isn't just Solidity, in my opinion. I would like to give a broad overview of the differences with both how you build smart contracts. If we're just going to focus on smart contracts right here, right? That subsection, how you build smart contracts and the available tools there. So that's going to cover development frameworks, the languages between Solidity and Viper, if we're talking about compiling to the EVM, and that types of things. And then so you have that part, which is developing a smart contract and how you do different security mitigations inside of building smart contracts. And then you have the other available tooling, which is checking it. So some tooling checks the EVM bytecode. Some tooling checks Solidity. Some tooling is built into the language itself such that the compiler fixes it for you. And so the different available tooling addresses different parts of the development cycle of a smart contract. And I'm hoping to cover all those things. If we can't cover it directly in the lecture, additional reading material, people in the channel and other juntos might help us backfill all that stuff, because there's so much. Because last time we had a lot of stuff on Viper, working with the Yearn team, right? Because all their code is written in Viper for specific security reasons. And the last two workshops from last block, which you can go look at, help you understand kind of why they made those decisions and how the Yearn vaults take advantage of that security stuff. And they're in this channel. You can ask them those questions. And so, in short, yeah, I want to be as broad as possible. I don't want to focus on things we could do a whole thing on Solidity development, or doing best practices. This whole course could be that, but I want to give you a broad overview of what exists today and where to go to find more information, so that whatever you're interested in, you can get better at that.
Awesome, thanks.
And the last one here I have from Moti is, There seems to be an over-reliance on security audits by trusted experts and organizations in the space. What are your thoughts on the state of automated tooling, Slither, Mythic, Securify, Critic, et cetera, and their use in securing smart contracts? This is a wonderful question. Carl, did you already start answering this? Yeah, you did. So bit. Carl replied in the Slack. Go ahead.
Just that, like with the automated tooling, it's great for the common pitfalls that you could miss where audits look more abstract and find narratives. So what may be automated may not be able to found by a process that would be not expected by the code.
Yeah, to add to that, the course is set up in such a way, well, the last course we did more sessions. We did one every week. That was more of a lecture, but it wasn't as much hands-on as I like it to be. But the goal is to help you understand how each of these things fits together and where they're most useful. So like when you think about the automated tooling available, Slither, Mythic, Securify, Critic, et cetera, that's used by auditors. Like they use that to try and find the easy bugs first if you didn't do it yourself. So this comes into play in a few different ways, right? So if we just look at automated tooling, for example, real quick, we don't have too much time. Automated tooling is useful to quickly find all the easy stuff that happens ubiquitously, or like the deterministic stuff that will happen within a code base. Like you can find reentrancy bugs because tooling can see that in the bytecode. And so what that does is it allows both a software developer and an auditor to find things quickly. What's great and how you maximize the efficiency of an audit is if you as a software developer do all this stuff first, because it's open, it's available, and you should be doing it anyway in the development process. That way, you get two benefits from that as a software developer. You know that you've covered a lot of the low-hanging fruit that's available through free and open source software. If you spend a little bit of time figuring out how to use it and applying it to your software development cycle. And then once you've done all those things, you know where risk lies and what you don't know anymore. Or you're more equipped to understand what risk is left. And so that way, when you engage an auditor or a third-party reviewer for review, you're better equipped to ask them what to look at and provide them with things you've already done. So you're not wasting your money and their time doing things you could have done yourself. And that's incredibly important because getting a review is hard and expensive and it takes time. So when the process of asking a reviewer to look at your code, you need to be really, really specific in what they're looking at, both from them understanding how to get to that point quickly and you not wasting your time and money. And I'm hoping that we can kind of give you that framework of how to get there. And it looks like all the questions.
There was one more that just popped up in chat. Do you see that one, Corey? Or did we get
I'm scrolling down. Question about authentication. You got 5 minutes before this is officially over. See what I can do here. What about using
before you do it, Corey? Is there anything that you wanted to wrap up with? I know we don't have that much time.
No, talk on the Slack. There's a bunch of people here. Use them. I'll be adding a bunch of additional resources. I wrote a long article, I want to say last year, this year, I forget. That was like a good summary of what I just said, which is what is a security audit, when to get one, and how to figure out what to ask, basically. And it's a long audit on all those things. It's about the tools you should use to prepare, how to define scope, how to do a timeline horizon of how long it should take, how to create requests for proposals so you can engage auditors, and then how to narrow down what type of security firm you should be looking for in the first place, things like that, right? So that you can maximize the process of the security review process. And if you'd like to be a security reviewer, you know the types of things you're looking for and the types of things you should know how to do. So like that article will be a pretty good kind of overview of kind of the steps in place and where they fit in. And Dan, who just mentioned something in the Slack, is an incredible resource for finding up-to-date information on how things work, where to go, and how to find a job afterwards. So for the question, got a few minutes. Question about authentication from Alexandra. What about using what we have now with face recognition and pass thoughts? Pass-throughs? Pass thoughts? I don't know what that is.
Pass thoughts. It's like where you can use EEG data. So your EEG data in your is completely unique to you. How you can use that as a password or an authentication for a human.
So I think the concept of it's 3 pillars of authentication still applies a lot in the secure in like the Web3 ecosystem, and that is what you are, what you know, and what you have. Choose at least 2. And biometric data, which I would bring EEG type stuff. I would put that in along the biometric data as being what you are. So there's a difference between, there's also that same difference between authentication and authorization. Proving who you are is different than proving what you should have access to. And so understanding some of the boundaries of there, which is really focusing on the access control mechanisms and what's most valuable for the risk at hand is applicable here. So like whatever we have in our disposal to figure out the best method for protecting risk should be used, particularly like those 3 pillars: what you are, what you have, and what you know. Because keys are what you have. You're not memorizing keys. Some people have seed phrases, sure, not a good idea. In my opinion, seed phrases should go away completely anyway, but that's a different story. But I think as we get better about, I want to be wary about spending too much leverage on what you are as a way to do things in this ecosystem, because the moment that gets deobfuscated is the moment it's broken, because you can't change who you are. So if you've leveraged too much onto biometric data and that gets compromised somehow, you can't change it. You can't rotate keys, things like that. So it should be leveraged appropriately, if that makes sense.
Cool. All right, Corey, I think we got there. How you feeling?
Good. I can talk about this stuff for days. So
we will. Cool. Well, thank you everyone for your questions. I said this at the end of the DeFi session, and Corey just said it. The conversation that we lead in Zoom is probably secondary importance to what you see in Slack, and the people that you see around there, the types of projects and people that we hope you'll have space and time to work with Carl leading that portion of it, while Corey helps us think as broadly as we can about Web3 security. So excited about this. Thank you all for being here. Keep us informed and in the loop on how you're feeling on the sessions. We'd love to get your feedback and keep it rolling.
Yep, thank you. If something sucks, let me know. I'll try and fix it.
That's our job. All right.